Hey everyone, this is 7.3 trigonometry sides, and in this lesson we're finally going to dig into actually solving for sides on some triangles. So we're actually just going to start with an example here, and then I'll talk about the steps and just kind of concrete your notes a little bit after we get through this example. But go ahead and draw this in your notes. And what you're going to notice is that we're given just one side. We're given the side 20. The other two sides are missing. So we couldn't use Pythagorean theorem even if we wanted to. Yes, it is a right triangle, but in order to use a Pythagorean theorem, we would need to have two sides. So that's where trigonometry becomes useful when you're only given one side, but you're given an angle. Okay, so first thing you want to do is you want to label your sides. Okay, we don't really care about this side over here. There's nothing there, so we can kind of just ignore that side, but label the other two sides. So across from the right angle is your hypotenuse. So label that, and I usually just do HYP. And then across from this angle that you're given, we're given the 60-degree angle. Across from it is the x, so that's our opposite side, and that's what we've been working on so far in this lesson. Okay, now next thing I want to show you, this is really, really important. So before we forget, I always do this like right away. As soon as I get a trig problem, I get my calculator set up. So I'm going to show you on the Desmos calculator, and if you have a different calculator you like to use, just let me know and I can help you get it in the right mode on there. But what we want to do is get it in degree mode. A lot of times calculators will default into something called radians, and we want to be in degrees. So on the Desmos calculator, you click this wrench in this upper left, upper right hand corner, and then you scroll down and you click degrees. Okay, so that's a very important step. Regardless of which calculator you're using, you want to make sure that you get it into degrees. Okay, after that, you need to decide which of the three trig ratios involves opposite and hypotenuse. So we have the O and the H, so we need to think back to SOHCAHTOA, and that's the one that we have. We have O and H, so we have sine. So we're going to set it up like this. We're going to say sine of 60 degrees is equal to opposite over hypotenuse. So in our case, opposite is x over hypotenuse, which in our case is 20. Okay, so that's the setup. Now it looks complicated, but it's really not. As long as you remember your SOHCAHTOA, you use the right trig ratio, and then you set it up like we've been setting up in the last couple lessons, you should be just fine. Okay, from there, we need to get x by itself. Okay, it's just like solving any other equation that you have in your whole entire life. You want to get the x by itself. Well, right now, x is being divided by 20. This fraction bar means divide by. How do you undo divide by 20? You just multiply by 20. So you just multiply by 20. And whatever you do to one side of an equation, you have to do to the other side of the equation. Okay, by doing that, you are allowed to cross off those 20s. Okay, we undid divide by 20 by multiplying by 20. Okay, so now I'm going to rewrite this. I'm not always going to do this, but I'm going to do it for this one just so you can see it. We have 20 times sine of 60 degrees equals x. Okay, well, x is by itself. That was easy. Now all we have to do is type it into a calculator. Okay, so I'm going to go back to the Desmos calculator and I'm going to type in 20 times sine of 60 degrees. 20 times. If you hit functions, you can find the sine. It'll open parentheses for you, and then you just type in 60. And since we're already in degree mode, we're just done. We don't need to type in the degree sign. Okay, and then we'll just get in the habit of rounding to the nearest hundredth unless it says otherwise. So first two decimals, we're going to look at the third at this 0 to decide where to round, and we're going to stay the same since it's less than 5. So 17.32. So x is 17.32, or 17.32 equals x, and we're done. Okay, always a good idea to just double check and make sure it makes sense. Your hypotenuse should always be the longest side, so if we got something bigger than 20, definitely wouldn't be right. If we got something negative, that's not going to be right. If we got something really teeny tiny, that's not going to be right either. But 17.32 seems fairly accurate. All right, so I want you to write the steps down in your notes. I think in trigonometry, sometimes it just gets a little bit overwhelming because it's kind of a lot of steps. So I'd like you to put that in your notes. So step one, Make sure your calculator is in degree mode. I'm actually calling that step 0. Once you have done it if you have your own handheld calculator, you really only have to do it once. But if you're using Desmos, you're going to have to do it every time you open up the app or the website. Okay. Step 1, label your sides: opposite, adjacent, hypotenuse. I'm going to add that. You're either going to label them opposite, adjacent, or hypotenuse. All right, next step, identify the correct trig ratio. So are we using sine, cosine, or tangent, depending on what two sides we labeled in the step above. Step 3, set up your equation. So as we did in the example, we had sine of 60 equals x over 20 or whatever it might be. Step 4, solve your equation for x, okay? Sometimes you're going to end up just multiplying by something. Sometimes they're going to be a little bit more work than that, but ultimately you just want to get that x by itself, okay? So let's go dive into one more example here. This one's going to be a little bit trickier, so definitely make sure that you get this one in your notes as well. So again, make sure your calculator's in the right mode. We just did one, so we should be fine there. Next step then is to label your sides. So this time, we don't really care about the hypotenuse. There's nothing over here. There's no x. There's no number there, so we don't really care about the hypotenuse. We do care about the opposite side. It's 10. And the adjacent side, then the side right next to 35 degrees, is your adjacent side. Okay, so now think back to SOHCAHTOA. It's definitely not so. It's not ka, but it is toa. It's tangent because it's opposite and adjacent. So we're going to set it up. Tangent of 35 degrees is equal to opposite 10 over adjacent x. Okay, this one's a little bit more work. This time the x is on the bottom instead of on the top. So it's going to be a little bit longer of a process. So first thing you should do is still multiply both sides by that denominator. Anytime you want to get rid of a fraction like that, you can just multiply both sides by the bottom. Okay, so now those are gone. Now we need to write down what's left. X times tangent of 35 equals 10. Okay, now remember the goal is to get x by itself. So think about that for a second. Right now we have x times tangent of 35 equals 10. If you want to get x by itself, you need to undo tangent of 35. Okay, it looks really bad, but it's really pretty easy. Opposite of multiply by tan 35 is divide by tangent of 35. Whatever you do to one side of an equation, you should also do to the other. Okay, once you do that, that allows you to get rid of the tangent 35 from the left side. So we're left with x equals 10 divided by tangent of 35, which can just be typed into a calculator. So x is going to be approximately, grab a calculator and do 10 divided by tangent 35. 10 divided by tangent 35 degrees, and we get about 14.28. For a final answer. Okay, so if you need any help with solving these equations, that's going to be the hardest part. Just let me know. I'm more than happy to sit down with you and do a couple of them. But really, it's no different from solving equations like you have been since middle school. Okay. One more example here. This one I'm just going to say is optional for your notes. If you feel like you got the hang of it and you don't need to do another one, you can certainly go on to the practice right now. But if you do need to see another one, I'm going to walk through one more. Okay. So we'll call it example 3. First thing we want to do is label our sides. So across from the right angle is our hypotenuse. And then we don't really care about that opposite side. There's nothing over there. But we do have 15 here, which we'll label as adjacent. Okay, so which of the 3 trig ratios is A and H? That would be cosine. I'm going to write that down just, okay, so ka, that's the one we need, A over H. Okay, so cosine of 71 degrees equals adjacent over hypotenuse, 15 over x. Okay, and this is like the last one, so it's going to be a little bit more work since x is on the bottom. So we're going to multiply both sides by x, cross that off. Now we have x times cosine of 71 is equal to 15. And then opposite of times cosine of 71 is divide by cosine of 71. Whatever you do to one side, make sure you do to the other side. Gone from this side. And then we're going to want to type this into the calculator. So I'll go ahead and do that right now. 15 divided by cosine 71. And we're going to get 46.07. All right, so go ahead and practice. And again, do not hesitate to let me know if you have questions. I know this can be a little daunting at first, but I promise you, if you keep at it, it'll be kind of fun.